Hello and welcome back. So we're setting up our project structure. We used npm to download all the dependencies, and we wrote some TypeScript code to create an initial Angular component. At this point, we need to compile the TypeScript code to ES5 JavaScript so that it can be executed by web browsers. For that, we'll need the TypeScript Compiler, so we need to add it to this project, and we can use npm to do that, like with other packages. We could edit our package.json file, but let's do it in another way this time. In our terminal, we can type npm install --save-dev TypeScript. So this means install the TypeScript package and also save it to our package.json as a dev dependency. Now this would install the latest version of TypeScript. We can also install a specific version by adding @ and the version number. In this case, I want TypeScript 1.8.10. If you're following along, please use the version you find in the text document provided with the previous lecture. I prefer to always explicitly specify the version numbers everywhere because things can change between one version and another, and I don't want my application to break just because npm automatically downloaded a newer version of some package. Anyway, this will download the TypeScript package, and now if we go back to the editor and open package.json, we can see that npm added TypeScript inside dev dependencies because we passed the save-dev flag. It's a dev dependency because it's only needed while developing this project. It's not needed to run the project. We need to compile TypeScript to ES5, but once that's done, we can take the generated ES5 code and run it. We no longer need the TypeScript compiler at that point. While all the dependencies we have above, like the Angular modules, are required to run our application. Right, now the TypeScript compiler requires some configuration that lives in a file named tsconfig.json. So let's create that file, and here we have a top-level object because it's JSON, and we can specify some compiler options. The first option we want is target, which defines what sort of code to generate. In this case, we want ES5 because that's what most browsers currently understand. Then we need to enable the experimental decorators option because Angular uses decorators like component, injectable, and so on. And related to decorators, we also need to enable the emit decorator metadata option. That's required for Angular to be able to use the metadata we specify in our components. There are many more options you can set here, but this is the minimum required for Angular applications. Now, if we close all the files and reopen app component, we can see that Visual Studio Code is no longer showing an error about decorators because we just enabled that feature in tsconfig.json. Right, if we look inside Node modules, we can see the TypeScript package there, but npm also added this .bin folder. This contains executable commands like tsc, that is the TypeScript compiler. So if we go back to our terminal, we can now run the tsc command. If we type npm bin, this will print the location of that .bin folder that contains all the commands installed with npm. So if we copy this path and add tsc, we can run that command. Let's add -v to just print the version. There you go. Now, on a Unix-like shell like bash, instead of entering the full path, we can also put npm bin inside $ and parentheses. So this will be replaced by the output of npm bin, and then append tsc, and it's the same thing, just more convenient. Note that this won't work with the Windows command prompt. You'll have to enter the full path every time there. If we run tsc-h, we can see the help for this command with all the options supported. But what we really want to do is compile our code, right? We can do that with tsc -root_dir source --out dir dist. So we're saying compile the files in the source folder and generate the output in the dist folder. If we run this, we see a bunch of errors. However, we can see that it has created the dist folder anyway, and inside it there are some JavaScript files like main.js that contains some code generated by the TypeScript compiler, and so does app.component. We've seen this before. When the TypeScript compiler generates errors, it doesn't always mean that it's completely failed. It can mean that there were some things it didn't like, but it generated the code anyway. However, we would rather not have any errors, of course. What it's complaining about here is that it cannot find some names like promise and map and set. Now, these are all global objects that have been added in the ES6 specification. We spent a full lecture talking about ES6 promises, right? So why is it that TypeScript doesn't know about this promise object? The first reason is that we set ES5 as the target in our tsconfig.json. Since we're generating code for browsers that support ES5 only, they won't have the promise global object or other ES6 objects and methods. However, we also have the core.js library as a dependency of our project, right? And this library provides all those ES6 objects and methods, including promise. So we basically need a way to tell the TypeScript compiler that we have a library that provides all these objects. But we cannot point TypeScript to the core.js code itself because core.js is written in plain JavaScript, so it doesn't declare any types or interfaces or the sort of information required by TypeScript. The solution is to provide a declaration file. This allows you to take an existing JavaScript library and declare the type of each object and method in that library so it can be used with TypeScript. Thankfully, we don't need to write such a definition file ourselves. There are type definitions provided for many popular JavaScript libraries. We can manage type definitions using another tool called typings. So we need to add it to our project first. And just like for TypeScript, we can do npm install --save-dev typings, and I'll use version 1.0.4. In your case, please use the version you find in the text document you downloaded. If we look inside Node modules, it has now installed lots and lots of packages because they're all required by typings, but somewhere we should find the typings folder as well. Now, if we go and look in the .bin folder, I guess I need to click the refresh button first. We can now see a bunch of commands, including typings. So let's close this folder and go back to the terminal. We can now call the typings command in the npm bin folder. Let's pass -v to see the version, and that works. -h will show you the help, just in case you ever need it. But what we wanted to do is find type definitions for core.js. So we can run typings search core.js, and this finds something. We can install that typings package with typings install, then we need to pass --global. Core.js is a global dependency in the sense that it provides global objects like promise. They're not objects we import explicitly into our code, like we import component from Angular core, for example. Then we pass --save, so it will save it to its own configuration file. We'll look at it in a second. And then, rather than just core.js, we need to prefix it with the source, in this case dt, like it shows in the search result. dt stands for definitely typed, that is a repository of type definitions. So we write dt tilde core.js, and this should work. It's a bit complicated. dealing with type definitions is probably the most annoying part of TypeScript in my opinion, but we just need to do it once for each project. So at this point we can see that it has created a typings folder and also a typings.json file. Typings.json contains the list of type definitions for this project, just like package.json contains the list of packages. So if we run typings install without any arguments, it will install everything specified in this file. The typings folder contains the actual type definitions. TypeScript declaration files have the .d.ts suffix. Let's look at this file quickly just to give you an idea of what type definitions look like. So the error we got from the TypeScript compiler was about the promise object. If we search for interface promise in this file, we'll find a declaration for promise. So here it declares an interface named promise that has then and catch methods. There's no actual implementation of the promise functionality in this file because that's provided by the core.js library that's written in JavaScript. This file basically describes what the core.js JavaScript code actually does, but in a way that makes sense to the TypeScript compiler. And that means by declaring interfaces and type annotations. Anyway, now that we have these types definitions, if we go back to our terminal and go back to our tsc command, in Bash you can search the command history with Ctrl+R. So if we run the TypeScript compiler again, this time it doesn't show any errors. Good. Let's stop here for this lecture. We've seen how to set up and configure the TypeScript compiler and type definitions with typings. In the next lecture, we'll see how to simplify our build process by using npm scripts. I'll see you later.